hello, welcome, and hello everybody. This is what you need to know about Windows Server 2016 security with me, Oren Thomas, and with
Gino Barletta, for those people who don't know me. So we have a full agenda. We have a lot of items, and I'm guessing that the reason you're all in the room, and it's really great to see you all here, is that you want to know a little bit more, or probably a lot more, about what is in Windows Server 2016, specifically about security.
And security is a very important part. I will interrupt you as we go along. So
that's all right. That's why we're co-presenting.
Okay, we're co-presenting. Security is the primary message of this operating system. So those of you who know that I'm a writer know that I'm writing Windows Server 2016 Inside Out, which is a nice 800-page, 200,000-word book on Windows Server. And when I've been talking to different product groups, when I was on the customer experience program for Windows Server 2016, the overriding message of why you deploy this operating system over Windows Server 2012 R2 is its security features. So in this talk, we're going to be shifting topics, going back and forth, but we're going to start with Device Guard and Credential Guard.
Absolutely. We're going to start with Device Guard and Credential Guard. We're going to talk about just enough administration. We're also going to talk about privileged access management, DNS policies, server,
Secure Virtualization Fabric.
Nano Server, for those people that want to know more about Nano Server.
Containers.
We're going to talk about containers and, of course, advanced threat analytics. So there's quite a lot to get through, so let's get started. So first and foremost, for those people who don't know me, my name is Gino Barletta. I'm a principal consultant for a hybrid cloud business technology company. So I work across a lot of organizations, predominantly in the enterprise and medium space. And the prime goal is to just educate, enable, and adopt of Microsoft technologies and that 1 degree. So that 1 degree today we're talking about is predominantly around security.
I'm Oren Thomas. Those of you that don't know me, I'm the IT Pro Regional Director for Australia. A regional director is like a super MVP. I write a lot of books. I'm up to my 40th. I wrote the Windows Server 2016 security course for Microsoft Learning. I've just done the Azure Architecture course, which is 18 hours of goodness for Pluralsight. There's also a nice 8-hour DNS course for Pluralsight if you're interested in that. But yeah, I do a lot of things. I'm doing 5 sections here at Ignite.
There we go. All right, so now, before we jump into what those components are, what I wanted to do was just take a couple of minutes and set the scene. So, as we know, security is on everyone's mind. I don't need to talk specifically about the public companies that have been attacked and credentials have been stolen and that type of thing. But, you know, James Comey, the director from FBI, puts it in succinctly. It turns around and says, it's not a case of if you've been hacked, it's a case of when you've been hacked. But the key thing here is to understand what has been hacked. So, as we understand, there is an attack timeline for when you get attacked. Now, what that really means is there is a preparation time. Now, no one really knows what that preparation time is. An example is there are people out there that live in the dark web, to use that term, that can probably sit for like months at a time and going, right, if we can attack some IoT devices and take control of those and use those to do some incorrect activities, what are we going to achieve out of it? And the end goal here is to achieve credentials. So from the research and preparation phase, this is where the next bit is to actually attack and get the goals. And the goals here is typically credentials. Now, the scary thing about this is the item, the thing is that most of the time these really smart people will get inside your systems and my systems and will sit and linger and wait for key opportunities.
And to give an example of that, some of you may have heard of the Target hack that happened a couple of years ago now. So what happened in the Target hack was a group of Eastern European hackers went into Target's systems. And this is a really clever hack. So what they did is what Target does in the US is every day they go and drop a new image on each of their registers. So each of their registers gets an operating system update every night. So it's a completely new image. What the attackers did is they got in through some HVAC vendor credentials. They went and then got onto the image server and created malware that reported itself as a Dell storage controller. And they infected the operating system image that was being deployed out to each register. Now, what was really clever about it, because they were waiting for exactly the right time, is that they only put that attack into effect a few days before Thanksgiving. So even though, because straight after Thanksgiving, biggest retail day in the US. So even though the IT team was sort of going, there's something dodgy going on here, their option was we turn off all of our registers on our busiest retail day of the year, or we just hope that all of these Dell storage controller things that are turning up in the event log are gonna be cool. So several million compromised credit cards later, I don't know what call I would have made.
And it wasn't me.
Someone dropped the bass.
Someone was Is it?
Keep going.
No, it's not me. All right. Okay. So, so what does that look like? So I'm just going to build this out because it's quite a complicated slide. So what does this look like? We actually start with an attack in your infrastructure. Because remember, the attack vector is not the network. Who here thinks the most important thing in your network is to protect your firewall and your perimeter network? Show of hands. Show of hands? No? No one. Wow, that's good. Because what we're trying to achieve here is once they actually get into your network, beyond the phishing attacks and beyond the living on either your workstations or your laptops, is to actually go and get the end game, the goal. And the goal there is to get credentials. And those credentials then get access, unlimited access, because they're at the administrator level. All you people here will have some level, if not the keys to the kingdom. And hopefully that by the time that a malicious attack has been identified, that you guys are in a position where you can not only identify what that is, but start doing a level of remediation. And I'm setting the scene with this now because the types of things we're going to talk about is exactly things that you can use and implement in your environment today to avoid getting, or should I say, other people getting access to your administrative privileges.
Or as the head of the NSA put it, it's much easier to hack a nerd than it is to hack a server. So if you can go and basically spearfish a nerd and get their credentials, and we see a lot of exploits happen this way, because people go and use the same password across a lot of things, don't they? Well, if you can go and get someone's password, or you can go and get them to prompt them to reset the password. In fact, the Democratic National Committee hack, where they got access to all of those embarrassing DNC emails, actually happened because someone sent a password request that looked legitimate, reset request, and then basically they were able to use that to get into a very senior DNC official's email. There is still a couple of seats down the front, by the way.
So as you can appreciate, Microsoft clearly understands that this is a big problem, and a big problem that needs to be addressed proactively and not reactively. So Microsoft, as part of the Windows Server security posture, has put down 4 key tenets whereby you can protect, detect, respond, and isolate to these incidents. Now, again, it's a busy slide, but the key message I want you to take away with is security is not a bolt-on, specifically in Server 2016. Security is a fundamental component of the architecture, and it's there from the ground up. Okay, and I think that's the next. All right, so two of the key things that I want you to keep in mind as we start talking about the components that we're going to talk about for Server 2016 security is it's about identity and it's about trust. If I, as a malicious person, not that I am, can get access to your identity and your domain admin, I can sit in your environment for as long as I like, create more accounts, and therefore build up a level of knowledge and when necessary, take that information either away or horribly start deleting information, which then is a potentially bigger impact to your environment. And that is where the last word, the trust, comes in. Because if you as an owner of data, an owner of keys to the kingdom, have a level of trust, the business is going to...
Just keep going.
Just keep going. Having a level of trust to make sure that you can deliver services as and when you need.
Cool. Okay, so...
All right. So let's switch gear and let's talk about Credential Guard. Quick show of hands. Who here has heard of Credential Guard? Right. Who here has implemented Credential Guard? One person. You don't own a BMW, do you? I had to put that one in. All right. So what is Credential Guard? Credential Guard is effectively virtualization capability of your identity on your computer, whether it's Windows 10 Workstation, I will mention a little bit about that because they share the same code base, as well as Server 2016. And the key thing there is it's all about having your identity, your keys to the kingdom that stay on your machine and it doesn't traverse. Now, why is this important? We all know that some of the script kiddie tools around, everyone heard about Mimikatz? The ability to go and attack a local LSA security and say, here are my users and here is the ability to grab passwords. What Credential Guard deters against is the attack against that. Is this the last thing I wanted to say? Through virtualization, virtualization-based security, which is VBS, not Visual Basic Scripting. All right, so what it does is, as I've already touched on, so if you have Server 2016 and virtualization capabilities, and we're talking about Hyper-V, this is enabled as a feature. Now, Credential Guard is not a feature or a role that you enable. It's a series of, when you add the technologies together, they will then enable via policy, which we'll talk about in just a moment. We've talked about Mimikatz, and of course, it requires modern hardware and configuration. Now, what does that actually look like? So I put this diagram in. So fundamentally, you need a modern hardware that has UEFI, and the UEFI needs to be in native mode. The second thing is you need a 64-bit operating system. Now, who here is still running 32-bit operating systems? Yeah, and I'm sure you have valid, not to call you out, which I already have, apologize. I'm sure you have valid business reasons, but look, I've still got customers that they're still saying, you know, God forbid, they're still running an older operating system and it's 32-bit. You need to run a 64-bit operating system. And as part of that, you also need SLAT, second level address translation. So whether your workstations, Windows 10, I know I touched on that, or Server 16, Intel or AMD processor must have SLAT. So think i5, i7, Xenon. So most of your servers will probably have that. And of course, the last one is you need TPM, the Trusted Platform Module for hardware security module within the server. Okay? Now, this is a busy slide. I'm not going to go through all of this. The key thing is there are a number of components that need to be in place. Within this slide at the end, you'll obviously get a copy of these slides. There is a number of links. So I've got references. You can go and look at the Credential Guard deployment guide, what you need to do to get going, how to do it step by step. All right. So what I've just covered is Credential Guard, making sure that the credentials on your server stay on your server and no other tools, even if they do get on it, can't be leaked or taken off that server. What if the device becomes compromised? What if the device, as I'm talking about here, Device Guard, that it's taken away? So what Device Guard is all about is policy-based, whereby certain applications, yes, in the server world, can only run. So think whitelisting of applications. Now, the first item I've got up here, people go, hang on a sec, doesn't Microsoft have AppLocker? The answer is yes, but AppLocker works in a slightly different context. The key thing about Device Guard is this is where you can define what applications are entitled to be run on certain computers. And the context here is Server 2016. So this is also suitable for privileged access workstations and secure environments. So think remote desktop servers, whereby you either have local users or remote users coming into Server 16. This would be another ideal use case where you could implement Device Guard. And of course, I've also mentioned that this is the same code base that's running for Windows 10 and Server 2016. Is there anything you wanted to add at this?
No, so I mean, the main idea of understanding Device Guard is that think of it more like you've got an iOS device where the hardware to a certain extent is being used to attest to security of the apps that are running. So what you want to do with AppLocker, it's possible if you can sort of find a way to mitigate the way that the group policies come down, you can actually then get an application to execute. With Device Guard, what you're doing is you're attesting to the entire operating system. You're really locking it down, and you're using hardware-based security to do it in the same way that you would encrypt something with a TPM for BitLocker. So Credential Guard and Device Guard specifically is a way of basically saying, right, this is exactly what my environment should look like. If an application gets infected, it is no longer going to match the digital security which we have authorized, so we're not going to run it. So the idea is that if you look at a lot of attacks these days, beyond phishing, you're looking at a lot of exploits that are coming in through different channels, such as the browser. It doesn't matter if you lock it down and you say, right, we're not going to execute code unless it's been authorized explicitly. And that's what happens on an iPad. The reason an iPad's really secure is that Apple basically only allows stuff that goes into the App Store, and then it's been digitally signed, and then that is not just done by the operating system, but by hardware. Well, think of Device Guard as being like that. And then you can go and do it on your servers, and I will talk a little later about how you can build that a secure virtualization fabric.
Okay, so on this slide, I just want to touch on the items in italics. These are the extra items that fit together that encompass Device Guard. And the key thing here, as I touched on right down the bottom, is it's all about eliminating untrusted code in your environment. Everyone here knows with a good degree of confidence what applications are running on your servers. So if you have another piece of application or another piece of software that you don't know that's running, Device Guard gives you that level of protection to say, hey, you know that Gino.exe that's running, right? That's not allowed to be run on my server. Out it goes. Right. So again, another quick diagram here to show you what it looks like. So the key thing with Device Guard is you definitely need secure boot. So depending on how you've got your servers architected, you will need secure boot. And of course, the key thing that's flashing there, you will need a TPM device. Very, very important. And of course, having the VBS, the virtualization mode, is going to require that your servers have the Hyper-V role enabled as well. Now, the great thing is that when you turn this on, Hyper-V actually becomes automatically enabled. It's not something, a special thing. And again, refer you later on in the slide deck, the Device Guard deployment guide, which covers step-by-step of what you need to do. Okay, so I'm going to change gear again now. So this is where Oren's going to talk about just enough administration.
Okay, so one of the, we've talked about sort of security at the operating system layer and the hardware layer. So controlling what applications can run is the first aspect of that. The next one is to talk about what can we do to protect ourselves against an evil universe version of ourselves. I'm actually giving an hour-long presentation on this tomorrow night. So what I'm going to do here is I'm going to go through the basics of it. If you find it interesting, you want to know how it all works and how to configure it and actually build it up from scratch, come across tomorrow. I think it's about 5 o'clock. And it'll be just in time, just enough administration. So the idea here is that if you think traditionally what's happened with administrators is that administrators have basically been superheroes. And I'm not just talking about us being all awesome IT pros. I actually did an interview yesterday with Channel 9 where we were talking about the difference between developers and IT pros. And one of the developers who was watching it just sort of tweeted me and said, show me where on the diagram the developer touched you. And I said, oh, if we could only start. But IT pros have always had an amazing amount of authority. And that's worked because that's allowed us to do our jobs. But it's also made us a great vector for attackers. As I said before, hack the nerd and you can hack the system. Because if you get access to what an overprivileged administrator can do, then you can go and do everything that administrator can go and do. So the idea with just enough administration, in a nutshell, is that instead of using, say, even role-based access control, where you're saying, okay, we'll do a sort of a permissions things where we'll give you access to these commands. With just enough administration, what you do is you create a special PowerShell endpoint. And what a PowerShell endpoint is, when you establish a remote PowerShell session, it's sort of like when you do an SSH session or a Telnet session. You go and create a session, you connect remotely to a box. Now, when you go and create a special one, what you do is you can limit the commandlets that can be used. And by limiting the commandlets that can be used, it's enumeration-based security. So you can't even see a commandlet that you're not allowed to use. So instead of, for example, allowing someone who is going to work with the DNS server access to every commandlet that's available on the box, what you do is you say, right, your job's to manage the DNS server. I will give you access to these DNS-related commandlets from the DNS module. And you can go further because you can lock down just enough administration based on parameters and parameter values. So you can say, not only am I going to give you the ability, for example, I'll give you the restart service commandlet. I'll give you the service name parameter, but I'm only going to allow you to restart the DNS service. So what you do is you go and create a special endpoint where someone who needs to perform an administrative task connects to that endpoint, and then they only have the tools in the toolbox, and they only have the size of tools to perform very specific tasks. So instead of someone connecting and being able to do everything, they can connect and they can do a very small amount of things. So the next thing it does is that it uses a virtual account. So you authenticate against the endpoint using, for example, a normal domain user account. When you're using that virtual account's running with elevated privileges. But the thing is that using just enough administration, you can set it up so that the admins in your environment don't actually have admin credentials with their normal accounts. It's just when they connect to an endpoint, they can perform an administrative task. Now, the other benefit of this virtual account means that that admin's credentials, that user account that's used to connect to that endpoint's credentials, are never stored on the target server. So let's say that you've got a DNS box that's sitting out on your perimeter network. You connect to a GEA endpoint, you go and perform your tasks, and then you disconnect. Now, in theory, if that box is compromised and someone runs Mimikatz on it, well, they can't pull any credentials because there's literally not going to be your domain credentials there. Every time you've done something, a temporary virtual account's been created. You've done it with that temporary virtual account. You disconnect from the session, the temporary virtual account disappears. It doesn't exist anymore. So your authentication, they'd have to come back to the domain controller and get there so that they could authenticate against the endpoint to actually perform tasks. It does include what's called the break glass option, where literally you can say, right, I really need to get out of this endpoint. I'm going to execute this command. And then you can set the parameters of that. And that might be that they need access to extra commands from the module, and you can set levels of that as well. But the idea is that as we go through and we document what processes particular people need to perform, what we can do is we can lock those out and define them in PowerShell, and that's the limitation of GEA, and I'll talk more about it tomorrow. We can lock that down and say, right, this person has got these rights when they connect to that endpoint. And then you just basically segment up tasks, and that's one way of securing it. So instead of having those Superman or Superwoman abilities where you can fly, you've got heat vision, you've got X-ray vision, you've got super speed and all of that, right, you can fly, but you can only fly between the Gold Coast and Brisbane. You can't fly wherever you want because the moment you stop flying that way, it doesn't work. So the idea is that the way that you stop rampaging administrator accounts is you lock it down. You assume that at some point someone's going to compromise an administrator account. So you limit the damage that it can do, right? It's like my 14-year-old son's just got taller than me. And he's like, Dad, can I try energy drink? I'm like, yeah, that'll go well. So he can wait a little longer before he's got, he's got all of those hormones under control before he starts just sort of start slamming down the V's and getting a bit hyperactive. So privileged access management can work in conjunction with just enough administration. So the idea is with privileged access management is that you have time-limited administrative privileges. Literally, what you do is you say, I want to do this. I want to go and create some users. So you log on to a MIM server, Microsoft Identity Manager server, and you say, I want to do this. And for the next 60 minutes, you can go and create users. 60 minutes expires, you lose the privilege of creating users. So think of it, instead of adding someone to the domain admins group or adding them to a group that's been delegated the ability to use permissions, you're adding them only to that group for a limited amount of time from which they are removed from that group. And the way that it works is basically the ticket lifetime is such that the ticket will basically expire, that their account is assigned, so that when they go and try and use the privilege when it's assigned, when the privilege has expired, they no longer get to do that. So that's the idea of privileged access management. You set it up with a secure forest architecture. The way a secure forest architecture works is that you have a bunch of standard user accounts in a secure forest. You then add them to special groups when they get approved in the production forest. So even if this account gets compromised, right? So let's say that we've got Gino's account, and Gino's got a standard user account in the secure forest. Now, when Gino requests it, he gets added to the equivalent of domain admins for 60 minutes in the production forest.
Woohoo! Domain admin.
Great. Now, let's say someone gets Gino's credentials.
Not happy about that.
Not happy about that. But they can't go into the secure forest and make any modifications because Gino has no privileges in the secure forest. And Gino only has secure privileges when he has been given authorization to do so in the production forest. So you can literally set things up so that, okay, so when an attacker usually comes in, they want to do it in the middle of the night. Well, who's going to authorize Gino with domain admin privileges at 3 a.m? In fact, you can configure workflows so that if it's out of Gino's hours of operation or if it seems unusual, no, we're just going to block him from getting those privileges. So you can build in a whole workflow. If it's something simple, like adding a DNS record, you'll allow that to happen within work hours, but someone will have to do a break glass or an elevate if it's out of work hours and they need to go and change, for example, an MX record. Because again, one of the common attacks that people do is that they go and redirect mail records, set up their own mail server, and then they get password reset emails sent to their mail server because their mail server that they're redirecting email to is suddenly picking up your domain's email. So it is based on an approvals workflow. It uses Microsoft Identity Manager 2016. So I will be going through that in detail tomorrow, but what Gino is going to do now is he's going to give you a little demonstration of just-in-time administration.
All right, so I'm just going to jump out of this and just bear with me while I bring these guys up. Okay. So this was just the end bit, wasn't it?
Yes.
Okay, so what I've got here in the, just to make sure that I type all these right. Now, I'm not going to type all of these because I'm actually going to do right at the end. So there is a number of PowerShell commands that you need to run. So the first thing I get every time I show this, people go, oh my goodness, it's PowerShell. There's too much to type. Don't freak out. You will get a copy of these commands so you can go through it step by step. Okay? So what I have here is I have, on my machine here, I have a domain controller and I have a member server. So what I'm going to do on the domain controller, as you can see, I've logged in as administrator. So the first thing I'm going to do is, so I've actually prepared this using the infamous cooking show. Here's one I prepared earlier. So in the program, Windows modules. So what I've done is I've created a new directory called DevOps. So what I'm going to show, sorry, I didn't set the context. What I'm going to show is the context of limited access for a user I've got in the domain called Beth, and Beth is going to have the capability only to do a subset of DNS activities, things like create records, A records, and restart DNS service. Okay. So what I've already done is in the DNS ops directory, should be nice and big, right? I've gone and created a role capabilities directory, and in there, there's actually two files, a PSRC, a PowerShell role capability file, and it's now forgotten, a PowerShell
Session configuration file.
Thank you. So how did I get those files? Well, running these PowerShell commands. So to get the first one, the RSC, what you actually run is, as you can see here, I make that a little bit bigger. There we go. All right, so for those people who wanted to take a photo. So this PowerShell command here goes and creates a PowerShell role capability template file. And this is what I'm about to show you right now. So this is a template, and the great thing is there's some examples that are in there, and you can just uncomment, as I'm about to show you, and you can augment and customize those. You can have one or you can have many based on what you need. So So by running that command, what ends up happening is you end up getting dnsops.psrc. That the one? Yes. Yay. All right. All right. So what we have here is, sorry, just demos. All right. So I'm not going to go. I'm going to go through this line by line for the. No, I won't do that. So you get the idea of what the file looks like, right?
We'll go through it line by line.
He will go through it in his session. We are restricted by time, but you get the idea. So line 26 is what I've added to say, right, for a restricted user, what commandlets will I permit? So in this case, I will permit, as I scroll across, the restart service, I'll just highlight that, the restart service, and more importantly, what service can that user restart? Now, so in this case, I've said, right, I'm going to permit or allow Beth to restart the DNS service. So as you can appreciate, you can add more items and you can add more services. We're just trying to go through this. All right, so the next item, wrong one. Got that. So if I just show this one here, I think you, in the presence of time. So not only can Beth restart the DNS service, but I've also given her function capabilities to add DNS records, clear the DNS cache, and get DNS server resource records. Now, of course, you could enhance that, or you could restrict it just to specific items. Okay. All right. Now, the other thing you can do as well is not only limit functions, but also commands. So in line 34, I apologize, I haven't highlighted it, you can also limit the specific commands that you can run. So obviously one of the ones that you would not want to put in is mimicat.exe. So in this case, the reason I've got whoami is what I'm going to demonstrate is I'm going to log on as a member server, log on as Beth, and before I execute the restricted commands to actually say how many total commands can I actually run, and then once I execute that session, you'll see the number drop, and then I'm going to validate my credentials by running the actual whoami command, so you can see that I'm using my virtual credentials connecting to, in this case, the domain controller. All right. Okay. Now I've saved that. Do I need to reapply and restart?
No.
No. Okay.
I mean, I don't know where you snapshotted, so but I'm assuming you're fine.
Right up to there, yeah. Okay, so. All right, so as you can see from here, I'm now on the remote server. And what I'm going to do, I'm going to log on.
Okay, so before you did Beth, did you want to go in as a normal administrator to see how many commands you wanted to have?
Sorry, yes. That's why I was logged in before. Sorry, just jumping ahead.
So what Gino's going to demonstrate first is what happens when you log on with a full administrator account and what you've got access to. And the way he's going to do that is he's going to log on and he's going to show you the number of PowerShell commandlets that are available to someone with full administrative privileges when they connect to, for example, a server that's hosting the DNS role. You've got your domain, so
Sorry, just
adatum/administrator. /, yep.
No pressure.
That's okay.
No pressure.
Close. Okay, so what you'll do is open PowerShell. And
Okay.
then connect enter PS session computer.
Oh, can do that bit first.
Yep. Okay, so what he's done there is he's established a remote PowerShell session to the remote computer. And the next thing Gino's going to do is he's actually just going to do a count very quickly of the number of commandlets that are available to an administrator. So we can see there that it's 2,260 commandlets if you're establishing a normal administrative session. So he's going to terminate that session.
Using
And then log out.
login as Beth. So now we have that number.
Now, Beth is a member of a special group that is authorised to connect to that PowerShell remote session. And only members of that group are authorised to connect to that particular remote session. So signs in as Beth, opens PowerShell. No.
Oh, just that.
No, you want this one here.
Oh, sorry.
So the command is enter PS session, computer name LUNDC1, and then you specify the configuration name. Now, the configuration name is the name of the endpoint that he'll be connecting to. That's okay. Okay, so there's an error there. But have you been able to make the connection or not? So do a who am I? I think that when you modified that command, that you might have, when you modified. So which? Where's that? Scroll up. Line 26. Go back. So MATERS. Did you say it?
No. What did I miss? Sorry. This is why you'll get a copy of these that you can copy and paste and not have to me fat fingers type it.
Okay, so now he has established a session to the remote domain controller.
Thank you for the collaboration. All right.
I need you as my editor. That's a great way of finding spelling mistakes there. Okay, so yep.
Oh, anyway, okay, right.
Okay, so jump back. Yep.
So now that I've established that session, and remember, logged in as Beth, if we then go and look at how many commands I have access to, restart. Wow, this is not good for me, is it?
Okay, so you can see there that we
Didn't
only have
sacrifice the
access to a small number of commands. So instead of 22,500 commandlets,
There we go.
we've only got that number of commands. Okay, so keep going from there. So do a who am I, find out who she's running as. So we can see there that it's actually not running as Beth's user account. What we can see there is that we're running as that virtual account. So none of Beth's credentials are stored locally on that computer. Okay, so we'll pause there and I guess we'll move on to the next thing. Now you'll see a much more extended version of that demonstration tomorrow. I won't do it with DNS, I might do it with something like Hyper-V or something else like that. I used to do it with containers and then they made it all Docker. And until they bring it back to PowerShell, can't do it with containers anymore. Okay, so the next one I want to talk about is DNS policies. And DNS policies are actually really, really cool. Basically what you can do is you can apply policies to the DNS server that determine how a DNS server responds to traffic. For example, you can filter traffic based on client, subnet, query type, or record name. So think of it this way. You can say, if you are on this particular subnet, you can only request A records or host records. You cannot request SRV records. You cannot request MX records. So what you're doing is you're specifying for the DNS server the types of records that someone who is an external host can query. You can even do it by record name. You can literally say, if you're on an external network, you can request these records. You can't request anything else. You can obviously use that to then do split brain DNS. In the past, setting up split-brain DNS has been a challenge. For those of you who don't necessarily know what terminology I'm talking about, what split-brain DNS is literally what DNS records are available to someone who's on the internet versus what's available to someone who's on the internal network. So someone on the internet, you want them to basically look up your MX record to find out where your SMTP server is. They might need to look up www.yourcompany.com.au, but they only need a small number. And so when you were running a domain environment and Microsoft was saying, well, name your domain, and you came up with, mycompany.com.au, part of you's going, yeah, but I don't want them being able to fingerprint where my file server is, what its internal IP address is. So with DNS policies, you can actually configure split-brain DNS literally so that, okay, internal network, you get access to the entire zone. External network, you get access to these records without you sort of pushing out a limited secondary zone that's available on another subnet, which is only limited to those hosts that you want. So you've got a much more option. You've got the ability to configure response rate limiting. In a denial of service attacks, one of the ways that people attack you is they just basically flood your DNS server with requests and it chokes and it can't hand out anything because it's basically backed up and clogged up and can't do anything. Sort of like when the pipes get full because your 14-year-old really likes those baby wipes and thinks that they're really good to use in the loo. And then your pipes get full and you have to call the plumber. That's my son's version of a denial of service attack on our toilet. Anyway, the joys of being a parent of a teenager. I mean, you don't know why your parents hated you. You really do. That's one of the things that you can do is you can configure response rate limiting. When you configure response rate limiting, you say, okay, if it's coming from this particular recognized subnet, and it can even detect, it can say, okay, I'm getting a lot of requests from this particular subnet. So what I'm going to do is I'm going to put response rate limiting policies in effect for a certain amount of time and then ease off after a certain amount of time. Because the thing that generally happens with denial of service attacks is the denial of service attack, they'll keep attacking you until it looks like it's either succeeded or it's been blocked. But they're not going to just keep it up. So with response rate limiting policies, what it does is it goes, oh, okay, you're attacking me. I'm going to, and you configure the policy, you say, I'm going to respond to only 10% of your requests. I'm going to respond to none of your requests for the next so on. Also with response rate limiting policies, you can do it by subnet. You can say, okay, if I'm getting denial of service attack from the internet, I'm going to stop responding to internet traffic. But my internal clients, I'm going to keep responding to. So I'm going to allow, in theory, if a denial of service attack's coming from your internal network against your DNS service, probably got other problems. But you can go and do that with response rate limiting. The other one is to disable selective recursion, or selective disabling of recursion. Now, as you may be aware, a DNS server, you can basically, if recursion is enabled on a DNS server, your client can request an address of that DNS server, and if the DNS server doesn't host that address in its cache or in its local zone files, it will go and resolve that query for you and return that information to your client. So for example, if your local ISP's DNS server, you look up www.google.com, your ISP servers obviously don't handle www.google.com as a zone, but they know where the root servers are, the root servers know where the .com servers are, the .com servers know where the google.com servers are, and the google.com servers know where www is. The Google servers hand back the www.google.com IP address to your ISP's DNS server, which handles it back to you, and that's DNS recursion. That is also being able to be used as a denial of service attack. So what happens is someone just keeps sending recursive queries at a DNS server, and it's like, oh, I'm going to try and resolve all the things, and it can't resolve all the things, and it has a nervous breakdown. So what you can do with selective recursion is you can say, right, for anybody who's on our internal network, handle queries recursively. So go and resolve a recursive query for any client that's sitting on the internal network. But if the client's on an external network and it requests a recursive query, deny them. Say, no, not doing it. If they request specifically a record for which your DNS server hosts a zone, yes, respond, because that's a legitimate query. But other than that, if you're a random client on the internet, I'm not going to go and give you the information you want on your behalf. You can go and query something else. Anyway, we've got a brief demo on configuring DNS policies.
Okay.
That's still the first one. What's the next one?
That
Oh,
was
you
it.
didn't have instructions for it. You had it just on the video. Do you want me to bring up the video?
Can you do it? Yeah. Should we switch over?
No.
Okay.
You can watch the video through this.
So do I log in as Beth
No. So you just do it all in with an administrative account.
on the server? All right.
I thought, did you practice this one or not?
No.
Oh, okay. So just give us a sec. Oh, that's nice. Why isn't that running?
Because I got the WAV file rather than the MP4.
Okay, so you wanted to do response rate limiting?
Yes.
Okay, so first one is type get DNS server response rate limiting. So, do you want me to do it?
Yes. Probably.
Okay. So the first thing I'm doing here is I'm logged on to a domain controller and I do get DNS server response rate limiting. And what this will tell me is that at the moment, response rate limiting is disabled. That means that there is no response rate limiting in effect. Okay, so what I want to do is I want to turn that on. And so what I do is I go set DNS server response rate limiting minus mode. Oops, the daisy. This is why when I'm doing a demo, I put it all in a Razer gaming device. Because that means my typing is perfect. And it says, do you want to turn it on? Yes. Okay, so the idea here is then if I go and look at it, that's turned it on. So the way that this response rate limiting policy will work is that by default, if there is, it will send 5 responses per sec or 5 errors per spec. So basically what it's looking for is over a period of 15 seconds, if there is more than a certain number of requests, it will enable response rate limiting for a certain amount of time. The maximum responses per window will be 1024. So in where it starts is if over 5 seconds, there's 1024 requests, over the average of a 15-second period, it'll turn on. So what you can do is you can minimize that or make it higher. And then when it does that, what it says is, okay, if response rate limiting is in effect, I'm only going to respond to 1 out of every 3 queries. You can go and change that so it's up to 1 out of every 10 queries, or you can say when response rate limiting is in effect, I'm not going to do anything for you. The next one I want to show you is how you can go and sin bin a particular subnet. Okay, so what I do, first thing I'm going to do is I'm going to do a get DNS server client subnet. And that shows me that I don't have any there. So what I do is I go add DNS server client subnet. Name, and in this case I'll call it honeypot subnet. And it's the IPv4, oops, I don't need to close that properly. IPv4 subnet. And then I'll say 172.16.101.0/24. Hit enter, okay? So the next thing I'm going to do is I am going to add a DNS server query resolution policy. And basically the way that this one works is I type CLS, add, oops, a daisy, DNS server. This wouldn't happen to me if I had a Lenovo keyboard. Those of you who know, I am a complete tart for Lenovo. Query resolution policy, Okay, so the name of this query resolution policy is going to be honeypot block. The action will be to ignore any traffic on the client subnet equal to honeypot subnet. So what doing that would do is that any client requests that come in from that specified subnet is simply going to be ignored by the DNS server. So rather than configuring a firewall at the operating system level, I'm almost configuring a firewall at the DNS server level. And that's how DNS query resolution policies work. Yep. So what will happen is it'll deny. So the DNS server will simply not respond to queries from that particular subnet. So you can go and build in with DNS query resolution policies a whole lot of things. You can say, okay, I am going to deny access to honeypot subnet for SRV records. So I'll go and allow it to do everything else except for these record class or these specific IP address ranges or the whole thing. So you can get very granular with these DNS firewall policies is another name for it. Okay, that's cool. We're not worried about that because we're not doing any more. Okay, that was our last demo. Okay, so the next thing we're going to talk about, which one of us is talking about this?
You.
Okay, so one of the other big bits of Windows Server security is NanoServer. So the advantage of NanoServer is that this is a new deployment option, and it's a bit of a, so Ben Armstrong's doing a talk on this as well. But the idea with NanoServer is that you can improve security by removing the number of moving parts or reducing the number of moving parts in an operating system. So if you wanted to deploy a DNS server, for example, you obviously don't need the ability to install Wins because Wins is always going to be with us. It's still in Server 2016. I don't know why. It was meant to go away with Windows 2000.
Oh, and Fax Server as well is still in Server 16.
Well, I'm not worried about Wins Server. I think Wins Server is still going to be there at the heat death of the universe.
That is an issue, yes.
But you don't need a file server sitting on your DNS server. So the idea with NanoServer is that you go out and build a server that has a minimal number of moving parts involved. You say it's going to be a DNS server, that's all it does. It supports a very basic variety of roles. Container host, virtualization host, DNS server, web server. You can have it as a scale-up file server. But when you deploy it, what you do is you actually build the image. So it's not like you install Windows Server normally where you install it and then go add roles and features and add the roles and features. With NanoServer, you say, right, I'm building an image. This image will only include the DNS server role. And it'll include drivers for this hardware. Or if it's going to run in a virtual machine, only the virtualization drivers. No other drivers. Because, of course, when you deploy a Windows Server image, it's got lots and lots of drivers for a lot of devices that you'll never use. It could be that one of those drivers might be the path for an exploit. So later on, eventually, it's going to support every Windows Server role. In fact, Jeffrey Snover, who is the lead architect of Windows Server 2016, has actually said that NanoServer is going to be the future of Windows Server. That in the long run, we're not going to be deploying these great general purpose servers where we deploy the server, then we add roles and features once the server's deployed. What we'll instead do is go, oh, I need to deploy that role. I will build a custom image for that role and I'll push that image out and that will be the server that will perform that particular function. Because this, again, is reducing the attack surface of what the server actually is. Think about it. So in terms of how big it is, it's 400 meg in size. So instead of deploying a 12 to 15 gig image, you're deploying a 400 meg image. Makes deployment very quick. In terms of spinning it up, you can spin up NanoServer in less than a second, depending on your hardware. So if you want to spin up a new server, very quick. Especially good for things like web front ends. It's part of current branch for business. Now, what this means is if you deploy NanoServer, it will be supported until the next +1 version of NanoServer is released. So if you deploy Windows Server 2016 right now, it will end extended support, I think it's in April 2027. With CBB of NanoServer, it's only really going to be supported properly for about 18 months, at which point you're expected to basically throw it away and then go and deploy a new one. Because it's very much more that idea of the DevOps deployment cycle. And what I mean by that is that you have fully automated the configuration of your servers. So that rather than sitting there going, okay, I'm going to keep patching this server because it's sitting in production for a long time, it's literally when it comes to patching it or updating it, what you're happy with doing is just doing a redeployment where it'll just automatically apply a configuration through desired state configuration. And then, for example, you'll copy the data back on as part of an automated process on that server. So that eventually you'll be moving towards a thing where, and the way that Snova says it, is treat servers as cattle, not pets. That you will get to the point where any of your servers you could replace very quickly because you've got all of that automated tooling in place to replace them very quickly. What you want to avoid having in your environment is a server where you have to take 3 or 4 days to build the thing because the configuration is so manual and so complicated. Because you think about the cost of replacing that server. 3 or 4 days to replace a server at your salary, and it's not what you're being paid, it's what you're worth to the organisation. That could be tens of thousands of dollars that it's costing the organisation for you to be faffing about fixing this server. If you can automate that process entirely, you're potentially saving your organisation a lot of money. So NanoServer is one way. The other way that it secures things is there's no local logon to a NanoServer. So if you spin up a NanoServer, you can't actually log on at console. You can log on and you can configure the IP address, but how you manage it is you actually have to make a remote PowerShell session to it. So all of that stuff I was showing you about, and we were talking about just enough administration, suddenly you're understanding how your NanoServer is being run because it's got a certain set of commandlets that are available. You can deploy it on bare metal, which means it's a great virtualization host. So think about it. You've got a 400 meg image that can host virtual machines. So the amount of RAM that's taking is sweet bugger all. And then you can host more virtual machines. But also if your virtual machines are running NanoServer, think of the density improvements of your virtual machines. Suddenly when you're deploying Windows Server, you're not asking it for 2 gig of RAM for each virtual machine that's running. Suddenly you can get away with half a gig of RAM. So where you could deploy one Windows Server running the server core operating system, you could deploy 2 or 3 NanoServers with the same sort of system resources. Also, because it's using far less disk space. Very quick to deploy. Now, containers are another technology that are important to understand and the context for them. So NanoServer is very good for certain workloads where you need to store data on the workloads. But there's going to be a bunch of workloads where you do not need to store data, that you need to spin up or destroy as needed. And you can do this with Windows Server containers. So I did a talk on this on Monday night, and I came up with the analogy that's really imperfect but kind of suitable. A VM is like a cat. If a cat gets sick, you take it to the vet and you try and fix it. Container's kind of like a guinea pig. Taking a guinea pig to the vet, sort of like refilling a Bic lighter.
Yeah, it's like...
It's harsh,
Yeah.
but it's kind of funny. Or an ant farm, which is probably far more politically correct, because someone said, what about if we name containers? I said, well, you don't think of containers in that way. Containers are ephemeral. You run an executing workload in a container. For example, a web front end. You need to scale up web front ends because containers start even faster than NanoServer because they're really, really small. Now, what a container does is it's a bunch of applications that are isolated from one another but share the same kernel. Each VM has its own kernel. So this is the way that you think about the difference. So if you've got an application, and this is your security perspective on it, right? If you've got an application that you trust, that you want to run lots of at scale, you go and put them in containers. Because that way, unless it takes out the kernel, they can all run together. So the container might fail, but unless it's doing something insanely weird with the kernel, it's not going to take down your container host. If you think it might take down your container host, that's where you go and put it in a VM. So if you really don't trust what your developers are doing, go and put their workloads in VMs. If you do trust, and it doesn't require persistent data. Because that's the thing with a container. With a container, you deploy it, but you never update it after that. The way that you update a container is you go back to the deployment image and you update the image, and then you deploy a new container from that image rather than and you kill the one that's sitting in production because it's just basically, running an IIS server, or it's running a web server, or it's just running the SQL engine. It's not the SQL data, it's the engine, it's the application execution bit. You can manage them using Docker, and that's how you do it at the moment. There is a bunch of PowerShell commandlets. So I did talk about that. Now, before I get to ATA, the other one I wanted to talk about very quickly, which we seem to have lost a slide on, is Secure Virtualization Fabric. This is the other big thing with Windows Server 2016. Secure Virtualization Fabric allows you to deploy a virtualization fabric that is trusted. What that means is that you can now deploy BitLocker encrypted VMs. What that means is that if you're the virtualization administrator, you can no longer go, oh, that VM looks interesting, I'm going to export that, mount the drives and look at the data inside it. In fact, you can lock off your VM administrator from being able to do anything other than start and stop the virtual machines that are running in your environment. So a secure virtualization fabric stops people basically exporting virtual machines. It stops administrators having any access. Anybody who doesn't have a local logon account to that virtual machine can't get into it. So the virtualization administrator can certainly see that it's running, but they can't see into the virtual machine. So this is Secure Virtualization Fabric, and this is a big point of differentiation between Microsoft and competing virtualization solutions, because Microsoft can now go, if you've got a secure workload and you need to protect it from your administrator, either because you don't trust your administrator or you're trying to protect against your administrator getting hacked, what you can do is you can deploy a secure virtualization fabric, which means every workload that's running there is only accessible to the people that should have access into that workload. And just because someone's basically the landlord of all of the virtualization fabric doesn't mean that they can come into those virtual machines willy-nilly, which they can do at the moment. Because at the moment, a virtualization administrator can go and basically put a boot sector virus in or boot sector malware and then boot the virtual machine and get access to it. Well, because these are BitLocker encrypted and the integrity of the VM is protected, if it's modified, the damn thing won't boot. So it's absolutely is a protected environment. No one else is doing this at the moment. So you can run BitLocker encrypted VMs in Azure. You can run DM encrypted Linux VMs in Azure. You can run DM encrypted Linux VMs in your Hyper-V data center, assuming that you have Server 2016 as your operating system, virtualization operating system platform.
So two other quick things. In addition to virtualized storage, what he just mentioned is that the virtual machines can also be encrypted at rest and encrypted in transit. So if you have virtual machines across your on-premise infrastructure, as well as a cloud-based service, or if you have a partner that you have another private cloud that you're working with, as they transition across that network, right, those virtual machines remain encrypted.
So if you're replicating, someone can't intercept the replication traffic and basically rebuild the virtual machine by intercepting replication traffic, because it's all encrypted.
Correct. Even if they do get access to that VHD, large as it is, we're probably talking 50, 100 gigabytes in size, they won't be able to mount it or start it on my or your Hyper-V host, unless it's your Hyper-V host, right? But if it's your Hyper-V host, you won't have the chance. All you have is just a very large file. Okay? Key differentiator here. Again, it's all about the trust of making sure that your workloads are protected in a manner that works in your environment. Now, thank you for that. So changing gear. So advanced threat analytics. Who here has heard of advanced threat analytics? That's good. Who here has implemented advanced threat analytics? Right. So in a nutshell, what is advanced threat analytics? Advanced threat analytics, commonly called ATA. So it's currently at version 1.8, and what it allows you to do, it's an on-premise solution that allows you to proactively identify and help remediate threats in your environment. Now, the key thing here is that this is the smarts through a whole bunch of cognitive analytics that can say, well, hang on a sec, what is deemed normal in your environment? Now, we've touched earlier today about DNS policies. So if you have an external attack of high amounts of DNS queries, then ATA can say, this is not normal. But if it's coming from inside, that may be normal. But what it will also do is work out through adapting, understanding your environment to say, this is actually normal between 9 to 5. but all of a sudden I'm now getting a high rate of attacks on a certain server at 7, 8, 9 p.m. at night. This is not normal. And what it can actually do is help identify false positives. So the way this does it is in 4 key steps. First one is it analyzes through deep packet inspection technology what's going on in your environment. Now keep in mind this is an on-premise solution, so it has the capability to look at what's going on. The second thing is it sits there and it learns to what is normal, right? In my environment, we have a different set of normal to what's in your environment. And the person over there who's got the BMW is probably different yet again to call you out. The third thing then is it goes and detects and says, hey, you know, these logon attempts, these 4 logon attempts across different workstations for the same user account, we don't think that's normal. And then the last thing is to actually alert. And that alerting can happen in a number of ways. Through near real time. So what that means is literally within seconds, you can get an email notification once you've set it up to say, hey, Gino is logging on from the domain controller and his PC in the office and his PC over in Europe. We don't think the PC in Europe is actually real. What are we going to do about it? So being alerted to it gives you that proactive capability. Now remember, right at the beginning, as I talked about identity and trust, ATA gives you the capability of understanding who the identity is, what the potential cyber attack is, and more importantly, be notified of that potential threat. It then gives you that capability, a significant amount of information very quickly at your fingertips for you to say, right, where do I need to focus my efforts? So what I've got here on the slide here is, this is an example of the ATA console. So for those people in the room that have got it implemented, this is pretty much normal. And what this shows is an example of an alert. Now this is an alert in the console. You can actually get an alert, for example, via email. So in this example, we've got a user, Jeff, and he's on a victim PC, and as you can see, he's enumerating a session. And as a result, he's trying to get to a domain controller DC1. Now, who here thinks that that, as an example, is really powerful, that's something you could use in your environment today? Yeah, thought so. All right. So, moving on.
Okay, so
All right.
in this session, we've talked about device guard, credential guard, just enough administration, privilege access management, DNS policies, secure virtualization fabric, nano server containers, and an ATA. Happy to take questions for the next 8 minutes. Otherwise, thank you very much for your attention.